Welcome back, Calcsters. Today we are going to start continuing on our discussion, moving a little bit past limits today. We're still going to keep using them, but in 1.3, it's going to take us today and tomorrow to get through. We are going to be looking at this idea of continuity. So continuity. Okay, just so you guys know, by the end, you guys are going to be able to tell if a function's continuous. Or write me the intervals of continuity. You'll be able to use all those properties, and we get the IVT, which is something that you've seen before. Total shot in the dark. IVT. Anybody remember it? It is an important one. It's a theorem. We'll get there. All right. So check it out. We had a bell ringer last week about continuity. Somebody remind me what we said continuous meant. Something about how you can draw it. You don't have to pick up your pencil. Like, that's the basic way for it. While we're looking today, we're going to be looking at continuity, of course. And this is kind of a definition, which is strange. But we're going to give ourselves a definition of continuity at a number. Continuity at a number. And this is our first big topic. All right. So for this, with your hands, show me real quick the limit exists. Okay, Fern, I'm going to pick on you for a second. I'm going to pick on a lot of you. Real quick, don't move your hands at all. If your fingertips are touching, I don't like it. Why? We don't have to touch. We get how close? Arbitrarily, infinitesimally close. They shouldn't be touching yet. After today, they will. So, as we're looking at it, you guys give me the idea of a limit. I'm good with that. Approach is the same thing from left and right, yeah? Why don't I make you touch? Like, why don't I want you to touch your fingers here? It could be undefined, right? We could have a hole in our function there, and then they wouldn't touch. So, when we're looking at continuity at a number, super easy. There's only three things that we have to worry about. We're just going to preface this with a function. A function is continuous, and I use CONT for continuous, and you'll see what I use for discontinuous in a little bit. We'll say a function is continuous, and I'll write it out this time. I would use a shorthand if I were you. At x equals c. If, and we have three requirements. That's it. So, one of them, if my function is not defined, would it make sense to say it's continuous? No, because you'd have a hole, right? You'd have to pick up your pencil. So, in no particular order, one characteristic, f of c is defined. That's the first thing that we need. Now, notice it could have a hole and then the point underneath, and that still satisfies this first part. Okay. Anything else you can think of? So if I want to say this function is continuous at some c value, and I'm just going to sketch some scratch work up here, don't draw it. I want to say it's continuous at this. I have to have that. Is that continuous function yet, though? What else do you think I need? So I need a line or a curve drawn from which side? Oh, the left and the right. Okay. So I'm okay with that. If it goes to the same value from left and right, like this, we say the what exists? The limit. So we need that. We need to have the limit as x approaches c of my function f of x. It has to exist. Now, notice, I didn't go through it all, but for this to exist, it has to be from the left and the right. Yeah, we need both sides of it. This covers both sides of it when I don't put the plus or minus here. Last thing, it's easy to knock out. This function is, what will be, is this function continuous right here? I think so, but we'll talk. Is this function continuous? Why? Can you, it's the hole right there. That's an issue. Now, it was defined, but it still didn't exist, right? So it's not continuous. Step 3, what do you think that limit has to equal? And I'm going to make you guys do a silly thing with your hands again. Here's how I do it. Right now, when I do this, I'm indicating what happens. The limit, it exists, yeah? Like here I am, check it out, I fill in the point. Like legitimately every time. Limit exists, not continuous yet, now it is. As soon as there's a point here, I need whatever that limit is to be exactly what this is defined as. That's it. Limit as x approaches c for my function f, well, it better be the exact same thing as f of c in that regard. Okay, these are the three things. I will always do this and use my head as a third point because I don't have three arms. Cool. Seem doable? Let's check. I have a couple questions for you. Together, or do you want to try one just with what we know? Try one. I like it. Okay, I want you guys to determine, is it continuous? And we'll say at ... We'll do a couple of these. So all we're really looking for is, are these three things satisfied? So let's deal with a lovely function here. F of x, and I'm going to give you guys about 60 seconds to get your ideas together, like talking as always, and then we'll call on random people. Here we go. I want f of x equals 3x squared minus 5x plus 4. And I want to know, is this function f continuous at x equals 1? You have three things to check. I'm going to give you 60 seconds. We might go a little longer, but I want you to talk it out with those three things. Does it fit continuous? Go. All right. For this, we only have three things, right? Okay. Every single time if we're asking if it's continuous, all we need is those three things. What's the first thing we should check, JJ? If it's defined. And apparently, oh, there it goes. Undo. Okay, so we say, is it defined where? What x value should I check? All right, let's do it. F of 1. What's 3 minus 5? Plus 4. So, was it defined? Check. I'm good. First step along the way. We're golden. Okay, what should I check next, Aisha? The limit as x approaches 1 of my function f. Now methods here. I don't have any weird stuff going on, no radicals, no dividing by 0. So what's the method I should try? Let's try direct sub. And what do I get? 2. Check. I'm good with it. From just these two things, realistically, the third one's just a nice little check. I'm not going to rewrite all this, but I just want to know, are these equal? I think so, right? F of 1 was 2 and the limit was 2. Okay, so check. Therefore, what do we conclude? F is continuous. Where? Give me the real value though. At x equals 1. You have to be crazy. Say at x equals 1. Be as specific as you can be. Super hard. Have we really done anything more than what we've been doing? I don't super think so. Thoughts, questions, issues? Feels okay? We did this one. I wanted you to do this one. I'm going to give you a little harder one. Now that you've seen it done, and hopefully it's easier than you're expecting, I want you guys to do one too. So here's B, and I will let you guys do this one by yourself. I'm going to set a 2-minute timer because it's a little bit more involved. We have a second lovely function. We'll call it g of x, and it's a fraction, just so you know. How crazy do we want to get here? Yep, cool. In the numerator, it's a lovely cubic. X cubed minus 25x. And downstairs is a wonderful quadratic, x squared minus 5x. Any guess at which x value I'm going to ask you about? 5 is a good thought. Cool. Riley, did you know 5? Am I doing the same one in your book? Okay. Cool. I'm going to set 2-minute timer. We'll see where we're at. Cool. Why won't it pause? Pause. Got yourself maybe struggling. Let's clean it up. First thing I'm always going to check. If it's defined. So let's check it. I'm trying to do at f of, or g rather. G of what? G of 5. So without showing a ton of work, 5 cubed, 125, minus 25 times 5, 125. Okay. Is my brain screaming trouble yet? Not yet. Now, you might know what's coming, and maybe I should be screaming trouble, but not yet. I'm okay with 0 up here. Denominator, though, 25 minus 25. Well, what did we just determine about my function? It's undefined, which is one of the 3 characteristics, right? Do I need anything else then? Boom. Not continuous. I'm going to say, therefore, not continuous at x equals 5. That's it. If you get checking and see that your function is not defined, don't even bother checking the limit. With that said, should we check the limit? Okay, I'm going to go really fast, okay? All right, when I do this limit, 0 over 0, I have some approaches, and this is totally optional, but as long as you're listening and thinking through it, when I take this limit, I have to rewrite it. What comes out of the numerator? Everybody see that leaves an x squared minus 25? That's the difference of squares. X minus 5, x plus 5. Over, factor, x, and leave behind x minus 5. They gone, they gone. The limit's 10. And we can see the limit's already 10 right then and there. Did it match my undefined value? So I'm convinced even a step further that this is discontinuous or not continuous. Cool? All right. You may not be here with factoring yet, but we're going to do enough of it that we will all get here. Like, I'm sure of it. Sweet. So, a little bit forward, and we're going to have a little bit of time for homework today, it looks like. But let's check it. We have, with our discontinuities, so let's see, we talked about continuity at a number. We better talk a little bit about discontinuity. Okay, you will never see me write this word again outside of definitions. Discontinuity. Henceforth, disco. All right. Now, there are realistically 3 types of discontinuities that you're going to encounter. 2 of them show up really, really clearly, but let's just list them. First one, we have a removable discontinuity. And removable. Okay, we'll get a picture of it here in a second, but because I'll draw them all down here. You know what? We'll just draw it right here. Removable. Here it is. I'm going to do a really lazy sketch, and I would ask you hold on before you do yours. So I'm going to have a function here. The one that I've just drawn is continuous. Are you guys okay with it? Now, let me just remove one little spot of this function. Boop. At this point, is it clear that I've just removed it? Like I've gone from completely continuous in this one little spot, I've removed it. That's it. That is our removable discontinuity. Now, the big telltale sign for this, without having to graph it, because it'd be nice to answer these things without having to build our graphs every single time. If we have a removable discontinuity, there's a couple little ways we can sum this up. The limit, as x approaches c of f, it exists. But what doesn't? If this is c, what doesn't exist? F of c. So I'm just going to say, but not equal to f of c. Now, we could say f of c does not exist. Turns out I don't really care whether or not it exists necessarily, because if I put a point right here, now f of c exists, but it doesn't equal the limit. That is a removable discontinuity. Okay. Alternatively, little pro tip, we have a removable discontinuity when something divides out. Something divides out. All right. Let's get our, God, there's a famous English, there's a bunch of books about him. He's an English detective. He has a sidekick. Benedict Cumberbatch made a movie about him. Hey, let's channel, weird, our inner Sherlock Holmes. So we're going to use our powers of deduction real quick. If a removable discontinuity is something we're talking about, thoughts on another type? So it is either it is removable or it's not removable or non-removable. Let's knock it out. Non-removable, I'll use some dashes. Non-removable. You will see me write non-remo, just so you know, but I'll write it here. Now, I'm going to leave a little bit of space because it does have another name, but I think that this one is really fitting for this. If I draw same little graph, and I'm going to leave that space that I just talked about leaving. Okay, we've seen functions that do this. Is this fundamentally different than the one that we saw for our removable discontinuity? Is there another name that you might use for this? And I'm going to do this real quick. What does he have to do? He has to jump. It's a jump discontinuity. That's the really common language that we use for this. This is a jump discontinuity, or a jump disco, if you will. Jump. So, oh, go ahead, Rafa. I thought you were saying something. Help me define this one with limits and such. Does a limit exist? Why? The y value, let's be more specific. I'm going to add a little bit, I'm going to put c here just so we can talk about it. If I ask you to take the limit as x approaches c from the left of f of x, is it the same as from the right? And that's that no limit exists. Everybody who shook their heads no, like I'm good with your answer. I just want to make sure we can formalize this. If the left limit does not equal the right limit, you have a jump discontinuity. Boom, that easy. All right, there's one more type that we talked about the other day. My student teacher, she said it in a way that made me hate her more and more. What's that word that I'm after? Asymptotes. What does a function do as it gets near an asymptote? It doesn't just magically stop normally. It either goes way up or way down. Okay, we have infinity, right? We have infinite limits as well. Rather than listing them right here as this type of discontinuity, we're going to see it in our next section because it fits in with a better, it fits in better there than it does here, but it does exist. Keep that in our heads. Okay, so as we're looking at these, I'm going to put some graphs up on the board. You guys don't need to look at this, but I do just want a good idea here. So here I have some functions that are kind of continuous in some places. Can everybody see? I'm trying not to show all my stuff underneath. Okay, a to b, all these things. I didn't put a to b everywhere. Is this continuous on a to b? Is there a notation that we use to say we use the endpoints? Like if we're writing an interval, anybody remember how to write starting at a and ending at b? I'm going to show one more. Brackets on a and b looks familiar. Okay. What does this one say when I say a to b? And it's clopin, which is a dumb word, but it is. What does this parentheses mean? Don't include it, right? Like we don't actually start there, we start close to it. Do we need to jot all these down in your notes, or can we just say, hey, look, there's a bunch of ways it can exist from one side and the other, or not? So I asked a terrible question that's not yes or no in that situation. Who would like to take a second to write down all these graphs in intervals? Bet. Cool. Let's save some time then. All right. I got a problem for us. And I guess, as always, do I have a problem for us or do I have a problem for you? Let's see it first, huh? Little editing magic to save time. What kind of function did I just write on the board? It's kind of like a piecewise, but it's a unique piece because there's no like less than or equal to, but it is a piecewise. I'm going to give you guys about a minute, or exactly 1 minute. I want you to come up with a plan of attack, and then I'm calling somebody random. Go. Only 3 things for continuity that we really care about. And in fact, there's 2, but we just check them at the same time, and you'd call the third one the check. For a function to be defined or continuous, we need it to be what first? Step 1. Defined. So I want to find me and you f of 4. Do we know what it is? You say 4, I don't know that I agree with you yet. Would I use the top or the bottom function? The bottom. When x is equal to 4, what value does it spit out? K. We don't know what it is yet, but it's K right now. Cool with that. Okay, that's like half the battle. What's the only other part we need? Don't just say the top. We need to make sure the function's defined and something else. The limit exists. So let's take the limit. And if we're approaching 4, are we actually getting to 4? No. So we're going to take the limit as x approaches 4. And if I'm not at 4, which function am I using? The top. Now, I'm going to rewrite this right off the bat. And I'm going to do some scratch work over here in case we need it. Because when I try to plug in 4, it breaks, yeah? Divides by 0. Shucks. This is my scratch work. If only there was a way I could rewrite that trinomial as a product of 2 binomials through the F word. Oh, let's factor it. Okay, is there a GCF? There's not one. Bummer. Is it a binomial? No, bummer. Is it a trinomial? What's the leading coefficient? Why do I care so much about that? Okay, we will take 1 times -4, and it gives me what? I need 2 numbers that multiply to be -4 while simultaneously doing something else. Okay, what was that simultaneously something else that you just gave me, Sean? Because I can see you did it. They have to sum up to that middle term. Okay, how does the shortcut work now that I've done all this? X minus 4 is one of my factors. X minus 4. And x plus 1 is the other one. Still all divided by x minus 4. Now, we had to factor, or we got to factor a little bit. Anything nice happen when we do this at the limit? Hey, peace out, peace out. What do I try now? Let's direct sub. And I think I can do it. When I direct sub, I don't divide by 0 anymore. Instead, I get 5. Everybody on board with that? Okay, so right now, here's where we're at. You do not have to draw it, but if you think graphically, does anybody graph this in your head? I'm not going to graph it nicely, just so you know, but it's actually going to be really bad right now. But here's what I know. I have the left and right, they approach 5. So I'll say here's 5. I know that as I get close from this side and close from this side, it's 5. Does the limit exist? I think so, right? Like I just did the limit. It does. Where should I, if I put k here, is it continuous? So I'm going to be real obnoxious with it. I'm going to make k like a huge point like this. You tell me where to stop so that my function's continuous. F of 4 could be 1 or 2 or 3 or 4, or if we stop right here, do we now have a lovely continuous function? And the only thing that I need is that my limits are the same as right here. What does k have to be? 5. There's no other option. If we want this to be continuous, k must be 5. K equals 5 implies continuous. Being okay with not knowing for sure what to do and trying. Like, this is a pretty common style AP problem where they say find the value. I'm pretty sure that I took a multiple choice and I just took your answers away so that you would actually have to do it. This is a really common problem that shows up on the AP test. Okay. I'm going to give you guys like 5 minutes to get started on stuff. So, this evening, and starting meow, we have homework 1.3.1. You will find homework 1.3.1 waiting for you on page 112. You get to work through problems 13 through 18, followed by 19 through 33 off. tomorrow we will knock out the IVT. For anybody who's just been bugging for the last 40 minutes, it's the intermediate value theorem. Cool. I'm going to try to grade your quizzes before you leave right now. I lied. I'll do it at lunch. Nothing. I didn't hear anything.